All right. The final operation we're going to talk about is matrix multiplication. Now, to do matrix multiplication, the first thing you need to look at is what the dimensions are on your matrices. For example, this is 3 rows, 1 column, a 3 by 1, 1 row, 3 columns, a 1 by 3, and C is a 2 by 3, 2 rows, 3 columns. Now, in order for us to be able to multiply them, the columns of the first one need to be equal to the rows of the second one. So we should be able to do A times B. But we can't do A times C because the columns of the first is not the same as the rows of the second. But we can do C times A. Matrix multiplication is not commutative, meaning you can't just change the order of how you multiply and everything comes out the same. So I'm going to first off try C times A. All right, so I've got a 2 by 3 and a 3 by 1. So because these are the same, this is legal. Now, what is going to be the size of the resulting matrix? Well, it turns out we looked at these inside ones to figure out if we were able to multiply them, but the dimensions are going to come from this row and this column. So my solution is going to be a 2 by 1 matrix. All right. So how am I going to get this first value right here in 1, 1? Well, what I'm going to do is I'm going to take a look at row 1 of my first matrix and column 1 of my second. So I'm going to look at this row in my first matrix and this column in my second. And what I'm going to do is I'm going to multiply, 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 and add all of those together. So in this case, 1 times 1 plus 2 times 0 plus 0 times 5. Add those together, I get 1. Let's try that again. This time I'm looking at 2, 1. So I'm going to look at row 2 and column 1. So 1 times 3, 2 times 2, plus 0 times 0. So I get 3 plus 4 is 7. Okay, so that's going to be my final answer on my matrix. Now, what is C times A? Well, C is a 2 by 3. A is a, well, I already did C times A. I meant, what is A times C? Sorry, 3 by 1. This is a 2 by 3. We can't do this, okay? Because these inside dimensions here don't match. The first column and the second row. Well, let's see if there's something else we can do. Let's try A times B. That's a 3 by 1 and a 1 by 3. Well, let's see. Those are the same there. And my dimensions are going to wind up being 3 by 3. Well, how am I going to find my answers here? Well, if I want to find 1, 1, I need to look at row 1 of row 1 of matrix A and column 1 of matrix B and multiply those together. So that would be 3. And then for row 1, column 2, I do row 1, column 2. Row 1, column 3. And then for row 2, column 1, I do row 2, column 1. Then row 2, column 2. Row 2, column 3. Then for row 3, sorry, I know this is getting all rubbed together. All right. So row 3, column 1. Row 3, column 2. Row 3, column 3. All right. And that would be my final answer. So whatever my location is, I'm looking at that row in the first column and that row in the first matrix and that column in the second matrix. Okay. Let's see if we can reverse this. B times A. So we can, because these inner ones are equal. And look, my dimensions are going to be a 1 by 1. I only have 1. So what do? I look at row 1 of my first matrix and column 2 of my second. So it's going to be 3 times 1, 0 times 2, plus 5 times 0. And there you have it. So the first important thing to do is, first, figure out if you can actually multiply them. Second, determine what the size of your matrix is. Third, take the location that you're trying to find that row in the first matrix, find that column in the second matrix, and then multiply those values and add those products together. There you go.